हेलो डियर स्टूडेंट, वेलकम टू आवर प्रॉब्लम सेक्शन वीडियो लेक्चर। आज हम रियल एनालिसिस की एक प्रॉब्लम को सॉल्व करेंगे और उसके बाद CSIR नेट के कुछ क्वेश्चन आए हुए हैं इस बेस्ड पे, क्वेश्चन बेस्ड, वो डिस्कस करेंगे। ओके, नाउ कम टू द सॉल्यूशन क्वेश्चन। व्हाट इज द स्टेटमेंट ऑफ क्वेश्चन? स्टेटमेंट इज द सीरीज, दिस क्वेश्चन इज फ्रॉम सीरीज, पॉजिटिव टर्म सीरीज, द सीरीज a raised to power 1 plus 1 by 2 plus 1 by 3 and up to so on 1 by n, where n is going from 1 to infinity and the condition on a is greater than 0 is convergent for a is greater than 0 and less than 1 by e. Those value of a, this series is convergent. So we have to prove that this question. So come to the solution part. We have to given that the given series is summation n is equal to 1 to infinity a raised to power 1 plus 1 by 2 plus 1 by 3 and up to so on plus 1 by n. Here comparing it with the general positive series, which is general notation is n is going from 1 to infinity a n. So by comparing we find out that this is the value of a n. By comparing both series, we get a n is equal to a raised to power 1 plus 1 by 2 plus 1 by 3 plus up to so on 1 by n. Okay, now we apply convergent test on this series. So first we apply D'Alembert ratio test. Okay, for this we have to find out that a n plus 1th term which represent a raised to power 1 plus 1 by 2 plus 1 by 3 plus up to so on plus 1 upon n plus 1. Okay, now what is the D'Alembert ratio test? We have to find the value of a n upon a n plus 1. Okay, this is a raised a n की वैल्यू ये है 1 plus 1 by 2 up to so on plus 1 by n, and what is the value of a n plus 1? It is a raised to power 1 plus 1 by 2 plus up to so on plus 1 by n plus 1 upon n plus 1. Now this term is cancelled on both sides, denominator as well as numerator. So it implies that a n upon a n plus 1 is equal to 1 upon, this is cancelled, it's remain a raised to power 1 upon n plus 1. Okay, now applying limit on both sides, we get limit n tend to infinity, limit n tend to infinity. Okay, and it's 1 upon infinity 1 upon infinity 0, a raised to power 0, ये हमारे पास हो जाएगा 1 upon 1 is equal to 1. So this is the value of n. What is the statement of D'Alembert ratio test? By D'Alembert रेशियो टेस्ट ये हमारे पास क्या होता है कि लिमिट n टेंड टू इन्फिनिटी a n अपॉन a n प्लस 1 इज इक्वल टू, अगर ये L है, इफ दिस लिमिट इज L, देन इफ L इज ग्रेटर देन 1 देन द सीरीज समेशन a n इज कन्वर्जेंट. इफ L इज लेस देन 1 देन दिस सीरीज a n इज डाइवर्जेंट. And if third case, if L is equal to 1, then this series is then case fail. We have not decided the series is either convergent or divergent. So by this result we conclude that this result is fail. Okay, now if you apply Cauchy ratio test, it is not applicable here. If you apply, then we get the value of again L is equal to 1. Then we apply Rabi's test. So that's why this question is important. So we go to first D'Alembert ratio test, it's fail. Now we go Cauchy ratio test, it is also failed here. You can easily done by applying Cauchy ratio test as well as Rabi's test. Okay, so we go here by this question is done by logarithmic test. ठीक है, logarithm test से हम इसको करेंगे तो यहाँ पे हमारे पास सारे केस फेल हो जाएंगे. Now what we can conclude that here here an upon an plus 1, its value is 1 upon a raised to power 1 upon n plus 1. Okay, and this can be written as a raised to power minus 1 upon n plus 1. Okay, now taking log both side, if we take logarithm both side, taking log on both side, we get, by taking log, it's log of an upon an plus 1 is equal to log of a raised to power minus n plus 1. Okay, now taking 1 upon n plus 1 is in front of log a, by property of log a, log of a raised to power b is equal to b log a. By this property we can conclude that it's log of an upon an plus 1 is equal to it's minus 1 upon n plus 1, या फिर माइनस को हम एज इट इज रखेंगे और इसको हम लिख सकते हैं log of 1 by a raised to power minus 1, it's 1 by a. Now multiplying by n on both side, we get n into n. Okay, and taking limit on both side by approaching n approaching to infinity, by taking limit on both side we conclude that limit n tend to infinity, and its limit n tend to infinity. Okay, so we can conclude that limit n tend to infinity n into log of an upon an plus 1, it is log of 1 by a, and what is here, this limit is 1. How? If we taking n common from both side, its limit n tend to infinity n upon n into 1 plus 1 by n is cancel out here, and is, if n is going from 1 to infinity, it's 1 upon 1 plus 1 by infinity 0, so 1 by 1 plus 0 1, 1 by 1 is equal to 1, so this quantity becomes equal to 1. Okay, or 1 into this, it become log of 1 by a. So by using what is the statement of logarithmic test, ठीक है, logarithm test हमारे पास क्या होता है, logarithm test होता है हमारे पास कि if this quantity for this positive term series, if this quantity limit n tend to infinity n into log of an upon an plus 1, ठीक है, this quantity become L, and if L is equal to 1, the case 1 is if L is greater than 1, then this series an is convergent, ठीक है, and second case if L is less than 1, then this series is divergent, and third case if L is equal to 1, then case fail, केस हमारे पास क्या हो जाएगा, फेल हो जाएगा. तो ये हमारे पास है logarithm test. So from here we conclude that this is the value of small l. So this series is convergent if L is equal to L is greater than 1. Okay, so by applying this result, this test on this positive term series, we conclude that this series is convergent if log of 1 by a is greater than 1. Okay, ये हमारे पास क्या हो जाएगा, greater than 1. Then taking exponential on both side, we get, this implies that 1 upon a exponential, by taking exponential, its exponential cancel out with log, it's 1 by a is greater than e raised to power 1, it's e. Is that clear? Now taking reciprocal on both side, we get, it implies that 1 by e is less than a. Is that clear? Then a is less than 1 by a. So we prove this here. So this is the condition for convergent. By applying second case, if we apply first case, if L is greater than 1, then series is convergent. So we conclude that, and this can be written as A is less than 1 by E. Okay. Now taking another case, second case, divergent if log of 1 by A is less than 1, and we find out that A is greater than 1 by E. So if A is greater than 1 by E, then this positive term series is divergent. So we conclude that if 0 less than A and less than 1 by E, then convergent. And if is A greater than 1 by E, then this series is divergent. And if A is equal to 1 by E, if we put A is equal to 1 by E here, we find out that 1 upon 1 by E, it's log of E, and log of E is equal to 1. So ये हमारे पास केस हो जाएगा. In this case, the test, if L is equal to 1, then case fail. So here, if A is equal to 1 by E, then logarithmic test is fail. Now if we go another test for the value of A is equal to 1 by E, it can be done by Gauss test. What is the statement of Gauss test? Here it is clear. I repeat for this. In first of all, we apply D'Alembert ratio test, and we see that this test is fail here. Now if you apply Cauchy ratio test as well as Rabi's test, you can get the value of L is again is equal to 1. So all these case are test fail here. So we apply last logarithmic test. By applying logarithmic test, we find out the value of L is equal to log of 1 by A, and applying all the cases, if L is greater than 1, then we find the condition on A such that the given positive term series is convergent, and applying the second case as well as third case, we find out when the condition on A such that the series is divergent. And if lastly we find out that if A is strictly equal to 1 by E, then logarithmic test is also fail here. So we go to the Gauss test. And what is the statement of Gauss test? The statement of Gauss test. What is the statement of Gauss test? If this is the positive term series such that the value of an upon an plus 1, we conclude that here it's alpha plus beta by n plus gamma n. This is the sequence. Here this is the sequence upon n raised to power p. If you replace n is from another value like n plus 1, result is also applicable here, where p is greater than 1, and this is a bounded sequence. If p is greater than 1 and gamma n, okay, this is a bounded sequence, then if alpha is greater than 1, then the given series is convergent. If alpha is less than 1, then series is divergent. And if alpha is equal to 1, then we have two cases. If beta is also 1, then series is convergent. And if alpha is equal to 1 and beta is less than equal to 1, then the series is also divergent. Okay, so this is the case. Now we conclude that here we discuss the case if A is strictly equal to 1 by E. If we put here A is equal to 1 by E, then it is e raised to power 1 upon n plus 1. Expanding this by exponential, we find out that 1 plus 1 upon n plus 1 plus 1 upon 2 factorial into n plus 1 raised to power 2 plus 1 upon 3 factorial n plus 2 raised to power n plus 1 raised to power 3 and up to so on. We expand this. Now this can be written as it is equal to 1 plus 1 upon n plus 1. Okay, here taking n plus 1 is common from this series, we find out that here it's remain 1 upon 2 factorial plus 1 upon 3 factorial into n plus 1, because the second 2 power is common. Next term is like that 1 upon 4 factorial into n plus 1 raised to power 2 and up to so on. Okay, this can be written as, now we assume that this is the value of gamma n. It can be written as 1 plus 1 upon n plus 1 plus 1 upon n plus 1 square, it's gamma n. What is the value of gamma n? It's 1 upon 2 factorial plus 1 upon 3 factorial n plus 1 plus 1 upon 4 factorial and n plus 1 square, and like that. This can be written as it is less than 1 upon 2 factorial plus 1 upon 3 factorial. Neglecting this term, this is greater plus 1 upon 4 factorial and up to so on. And what is the exponential of this series? It's less than, its value is e minus 2, because 1 plus 1 upon 1 factorial, it's 1. This term is missing, so taking these two term in left hand side, we get e minus 2 is equal to this. So this is a finite term, so gamma n is bounded sequence. Okay, now both the condition of Gauss theorem is satisfied here. The gamma n is bounded sequence and p is greater than 1. Here value of p is equal to 2. Now we compare this result, this expression with this expression. We find out that the value of alpha is equal to 1, and what is the value of beta? It is also equal to 1. Okay, it is also equal to 1. So we find out that by third case, if alpha is equal to 1 and the beta is also is equal to 1 and less than equal to 1, then the given series is divergent. So if a is equal to 1, then given series is divergent. Okay, so we conclude that if a is greater than or equal to 1 by a, then the given series is divergent. So by these result, by test, we prove that the series is where a is greater than 1 is convergent for 0 greater than 0, a is greater than 0 and less than 1 by e, the series is convergent. Hence prove. A similar question is come in CSIR NET exam. We discuss that question. Okay, this is the question from CSIR NET June 2017, and it is question from part B का question है ये. Come to the solution part. What is the statement? For a greater than 0, the series this a raised to power log of n is convergent if and only if. We have to find out that one option from these 4 options. Okay, now come to the solution part. The given positive term series is summation n is going from 1 to infinity a raised to power log n. Okay, now this series can be written as, we interchange the value of a and n here. This series becomes equal to series n is going from 1 to infinity and n raised to power log of a. This can be done by using property of log. ठीक है, it's log of a raised to power log of b is equal to b raised to power log of a. It can be done by we know that it log b and log a is also a real number, then it can be written as log of a into log of b is equal to log of b into log of a. Okay, now using the property log of a raised to power b, it's b log a. So from right hand side to left hand side, we can written it log of b raised to power log of a, and here log of a raised to power log of b. Now taking exponential as या फिर antilog on both sides, we find out that e raised to power, and we find out that b raised to power log of a is equal to a raised to power log of b. So this series can be written as this. So this is the proof by using this property. Now this series can be written as, it is summation n is going from 1 to infinity 1 upon n raised to power minus log of a. Okay, now using p test, using p test here, we find out that the series, what is p test? Summation n is going from 1 to infinity, 1 upon n raised to power p is convergent. First case is convergent if p is greater than 1, and second is divergent if p is less than equal to 1. So the given series is this, is convergent if minus log of a is greater than 1. Okay, now multiplying on both sides with minus 1, we find out that log of a is less than minus 1, and by taking antilog on both sides, we find out that a is less than e raised to power minus 1. It can be written as a is less than 1 by e. And what is given that a is greater than 0, so a is greater than 0. For this value of a, the given series is convergent. So the option 3 is the correct option. So answer of this question is option 3. This can be done by p test. Okay, thank you for watching.